The U.S. National Science Foundation is pleased to announce 4 mid-scale research Infrastructure-1 mid-scale R-1 awards for fiscal year 2023-2024 that will continue the agency's support of cutting-edge science and engineering research. The 4 awardees chosen exemplify the best of American science and engineering. Their design and construction of research infrastructure will deliver results that bolster national security, shed new light on fascinating discoveries, and lead to innovations that will benefit the American public. The mid-scale R-1 awards support the design and implementation of research infrastructure, including test beds, equipment, cyber infrastructure, large-scale data sets, and personnel whose total project costs exceed NSF major research instrumentation program but are under $0 million. By supporting cutting-edge research, NSF and the awarded research facilities will allow scientists and engineers to test new theories and questions in a novel setting, pushing science forward. The 4 awardees NSF has selected the University of Rochester, Iowa State University, the University of Washington, and the University of Southern California exemplify the most novel, innovative infrastructure being designed and built in our country to advance the best ideas and train the highly skilled talent in science and engineering for our future, said NSF Director Sethuram Panchanathan. By investing in the most innovative infrastructure, NSF aims to strengthen opportunities for all Americans and advance the frontiers of science and technology. Read more about the 4 FY 2023-2024 mid-scale R-1 awards below. Omega Extended Performance Optical Parametric Amplifier Line AP Opal University of Rochester. NSF has awarded the University of Rochester nearly $8 million over 3 years to design and prototype key technologies for the Omega Extended Performance Optical Parametric Amplifier Line AP Opal, a newly proposed facility dedicated to the study of ultra-high-intensity laser matter interactions that would be built at the Laboratory for Laser Energetics upon completion of the design project. EP Opal aims to enable the U.S. to recover and maintain its status as a world leader in the field of high-intensity laser science via design and prototyping. Technology developments over the last decade have enabled high-intensity lasers to promote both basic and use-inspired science across a broad range of problems in physics and astronomy, like particle acceleration, advanced light sources, and laser-driven nuclear physics. EP Opal is envisioned to provide laser capabilities beyond those currently available internationally, helping to re-establish U.S. leadership in the field of high-peak power lasers. This project will lay the groundwork for constructing a facility that would house the highest power laser system in the world. It would complement the NSF zettawatt equivalent ultra-short pulse laser system facility at the University of Michigan that is about to come online, as well international facilities like the Extreme Light Infrastructure National Testing Facility for Enhancing Wind Resiliency of Infrastructure in Tornado Downburst Gust Front Events and EWRITE, Iowa State University. Short-term windstorm events such as tornadoes, downbursts, and gust fronts cause billions of dollars of property damage and numerous fatalities in the U.S. each year. The goal of the NSF National Testing Facility for Enhancing Wind Resiliency of Infrastructure in Tornado Downburst Gust Front Events and EWRITE award is to design a university-based facility that will simulate realistic wind fields found in these windstorms and will enable physical testing of their effects on civil infrastructure using mid to full-scale models. To assist with the NEWRITE design, the team will design and construct a smaller-scale physical prototype of NEWRITE at Iowa State University and develop a digital twin of the facility. The outcome of this project will be final design documents for construction of the full-scale NEWRITE. Iowa State University will lead the e-design project with participation from Clemson University, Missouri University of Science and Technology, Northeastern University, Texas Tech University, the University of Arkansas, the University of Florida, the University of Washington, and the University of Wisconsin. This project is jointly funded by the Mid-Scale Research Infrastructure-1 program and the established program to stimulate competitive research, creating an offshore subduction zone observatory in Cascadia with the Ocean Observatory's Initiative Regional Cabled Array COSZO, University of Washington. Earth's greatest geological hazards are concentrated in subduction zones. These places where two tectonic plates converge and collide not only produce large-scale earthquakes, but suffer from their cascading effects such as devastating tsunamis. The Cascadia subduction zone, spanning the offshore coasts from northern California to British Columbia, hosts earthquakes up to magnitude 9 every few hundred years, the last of which was in 1700. Today, seismic and geodetic sensor networks on land in the Pacific Northwest can quickly alert authorities to geohazards, but the offshore region, where almost all the locked plate boundary and expected earthquake slip would occur, is largely devoid of such instruments. The University of Washington will lead the creating an offshore subduction zone observatory in Cascadia with the Ocean Observatory's Initiative Regional Cabled Array COSZO project to add geohazard sensing instruments, including seismic sensors and seafloor pressure gauges, to the existing NSF-funded Regional Cabled Array. The Regional Cabled Observatory currently brings power and internet into the ocean offshore of Newport, Oregon. Now, thanks to COSZO, it will produce real-time data that will help answer fundamental questions about how subduction zone faults work and will enhance existing systems for earthquake and tsunami warning. Research infrastructure platform to host reproducible cybersecurity experimentation SPHERE. Information Sciences Institute, University of Southern California. The University of Southern California Information Sciences Institute will construct the research infrastructure platform to host reproducible cybersecurity experimentation SPHERE testbed with its mid-scale RE-1 award. SPHERE is a research infrastructure platform for at-scale, realistic and reproducible cybersecurity and cyber privacy experimentation across varied infrastructure. This will facilitate both foundational and translational cybersecurity research. To cover the broadest range of experimental conditions, SPHERE will include a variety of hardware, including embedded/edge computing devices, devices for machine learning training and inference, cyber-physical devices and programmable logic controllers, Internet of Things devices, programmable network devices, and general computing devices. A key feature of the effort is built-in mechanisms to support reproducibility and replicability, a long-standing challenge in the cybersecurity research community. To democratize access and provide maximum utility, SPHERE will provide a variety of user portals and interfaces that cater to a broad range of users, including students, artifact evaluators, and advanced researchers. Overall, SPHERE will strengthen America's cybersecurity research faculties and allow for research and experiments to be reproduced while serving a diverse set of target user bases.